Okay, we're going to have a look at angles in a semicircle. Okay, now a semicircle is just half of any circle, so this could also be in a full circle, but going from any diameter. Any diameter obviously cuts a circle in half, so any diameter changes a circle into a semicircle. Okay, now if you have a triangle where one line is a diameter and the other two meet at the circumference, they will always meet at 90 degrees. So if I was to draw this round, if I was to draw this really accurately with rulers and draw this round like this and keep going, every single time I drew that in, it would meet at the point on the circumference at a right angle. So all of these here would be right angles. Okay. Information is really useful because we need right angled triangles to use Pythagoras, and it also helps us work out angles in a triangle. Well, angles in a circle in triangles, I should say. Okay, so if we have a look at the first one, calculating missing angles again. So we've got angle C, angle D. AB is a diameter, because it's a line going through the centre. C is on the circumference, so C must be a right angle, so C is 90 degrees. Here, we've got a triangle. Angles in a triangle add up to 180. So if that's 90, that's 35. To work out D, doing 90, add 35, which is 125, and taking that away from 180. Which gives me 55 degrees. So D would be 55 degrees. The other way we can use this is if we know that this is a right angle. So there's my right angle, that's a diameter. These two lines then meet at the circumference. This point must be a right angle. So if I want to find the length of this one here, it's the longest side of a right angled triangle, so I can use Pythagoras. I'm finding the longest side, so I'm going to square and add. 12 squared is 144, 5 squared is 25. This one could be done without a calculator, it might well be in a non-calculator paper. It's 169. So x is the square root of 169, which is 13 centimetres. Okay. You might want to pause the video there and try some of the questions on angles in a semicircle. You can keep going and do both at the same time if you prefer. Okay, tangent to a circle then. If we have a line that, even when we extend it, touches a circle only one point, it's called a tangent. So if we have a look here, we've got a circle. This line here doesn't touch the circle at all. This one here touches the circle at 2 points. This line here, however, only touches the line at 1 point, and it's at this point here. So that line is called a tangent to the circle. And the interesting thing about a tangent to a circle is that if we draw a radius down to that point of contact, so if we take a radius from the centre down to the point of contact, it meets that tangent at a right angle. Okay, and again, we're all about the right angles here. We like right angles because if we have a right angled triangle, we can use Pythagoras. And I will keep saying this over and over and over again, because whenever we're asked to find the length of a side in a circle, or even angles in a circle, we really need to be able to spot these right angles. Okay, calculating our angles again. So once calculate angles A, B and C. Looking at angle A to begin with. This is a diameter, so it's a line of symmetry. So if that's 90 degrees, that must also be 90 degrees. Also, tangent's a straight line, so it needs to add up to 180. So if that's 90, 90 add 90 is 180. Whatever reasoning you saw first. B, angles in a triangle. Angles in a triangle add up to 180. We've got 190, 170, 90 add 70, 160. Take that away from 180. Angle B then is 20 degrees. Angle C, tangent's a straight line, so these two angles here must add up to 180. So C is going to be 180, take away the 70, so C is going to be 110 degrees. Okay. I think you might have guessed what's coming next by now. Oh, no, we've got another angle one first before we find our length. Right, so we want to find angles P, Q and R. So angle P, there's angle P there. Is a right angle, is 35. So if we do 90, add 35 to that equal sign. See up here. It won't set me otherwise. Go. 90 add 35 is 125. 180 minus 125. Angle P then is 55 degrees. Angle Q, this angle here, there's a right angle, it's a line of symmetry, so that must also be a right angle. Angle R, here we've got a right angle, here we've got 45, do an equal sign again, don't need that in yet. Angle R, I can get just from my angles in a triangle, so 90 add 45, it's 135 degrees, 180 degrees in a triangle, minus that 135, so angle R is 45 degrees, which means this triangle here is isosceles, which is completely irrelevant at this point, but it is just nice to note. Okay, this is an exam question. So this is the kind of exam question that you can expect to get on looking at missing angles in a circle. So here we have a circle with a tangent. So we're told that this line LM is a tangent. Angle KLM, which is this part here, is 76 degrees. And we want to find the size of angle KOL. Now, if you think about naming angles, it might be a while since you've looked at naming angles. The one in the middle is the one where the angle is. So it's not that we need to name angle K, angle O and angle L, it's just this angle here. So I want to find the size of this angle here. Okay. Starting point then. The radius meets the tangent at 90 degrees. So that full angle there, that's clear enough for you to see, is 90 degrees. That part of it's 76. So if we do 90 take away 76, which is 14, that gives us the size of that angle in there. So that size in there would be 14 degrees. We have an isosceles triangle here. OL is a radius, OK is a radius, so those two are the same length. So if that's 14 degrees, that angle there must also be 14 degrees. Then I've got two angles in my triangle. Add them together. That gives me 28 degrees. All three angles in the triangle add up to 180. So we'll do 180 take away 28. That will give me 152 degrees. So KOL, and it's always good to state that you know that you found it, is 152 degrees. If you're not clear that you know that that's the angle that you're looking for, you might lose a mark for that one. Okay. Third example, PQ is a tangent to the circle and it touches the circle at this point R. And we want to find the area of the circle. Okay, so we have the length of PR, which is 8. We have the length of OP, which is 10. Neither of those help us. If we want to find the area of a circle has the formula A equals pi r squared. So if I want to find the area of a circle, I need to know the radius of that circle. Now I don't know the radius of this circle. So that's what I want to work out. So I'm going to make a right angled triangle here, and I'm going to do it by drawing in a line from the radius to the tangent, because the line from the radius to the tangent meets at right angles. And I'm going to call this R for radius, because that's what I want to find. 10 must be my longest side, so I'm finding a shorter side. So I'm going to subtract. So I'm going to do 10 squared, take away 8 squared. Well, again, nice numbers. Practice our non-calculator skills here. 10 squared is 100, 8 squared is 64. 100 take away 64 is 36. That gives me r squared. I just want r, so it's the square root of 36, which is 6 centimetres. Don't stop there. We haven't answered the question here. We have worked out the radius of the circle. The question asks for the area of the circle, so we need to keep going. So area of the circle, so A equals pi r squared. Radius we've worked out is 6, so we're doing pi times 6 squared. Pi times 6 squared, which is 113.1 centimetres squared. And we're finding an area, so units must be centimetres squared. Okay, last example then, number 4. Again, exam question. Or I can't actually remember, it might be just in one of the practice tests rather than an actual exam. Circular bathroom mirror has a diameter of 48 centimetres and it's suspended from the ceiling by 2 equal wires from the centre of the mirror. So that would be OB and OA, so they're both the same length. AB is a tangent to the circle and AC is 45 centimetres. Calculate the total length of wire used to hang the mirror. Okay, so we need to find out the length of OA. These two are both the same, so it doesn't matter which one I use, but I want to find the length of one of them. Whenever we are asked a question like this where we want to find a length of something involving a circle, we want to look for a right-angled triangle. We need a right-angled triangle so that we can use Pythagoras. Okay. AB is a tangent, so if I draw a line from the centre of the circle to the point where they meet, that would be at right angles. I know that AC is 45 centimetres, that's 45 centimetres. I know the diameter is 48 centimetres, which means my radius is 24 centimetres. That gives me the information I need. That gives me 2 sides of my right angled triangle, so I can find the third side. It's the longest side I'm finding, so I'm going to square and add. Do 45 squared plus 24 squared. Which is 2,601. Taking the square root. Get 51. Total length then, 51 is the length of one of them, we've got 2 of them, so we're going to double it. Helps if I write the right thing, doesn't it? 51 times 2. So it means 102 centimetres of wire. Okay, I'll leave you to try some of these.